late, but
You okay with this?
yeah, it's fine.
Thank you.
Let's see. So this is, we were talking last week about AI. I was joking that I now feel like a prophet of doom, as in the last 2 months I've been just walking around and developing. Everybody needs to learn about AI because this is serious. And then Alex and Andrea said, well, why don't you give a talk here? So this all happened since Friday. It'll be a little bit, I gave training like this before, so it's not going to be the first time I do it, but it might be a bit rough around the edges, so apologies if you noticed that. There are a couple of, so here's how I'm going to do it. Now, I'll start with a little bit of an introduction to kind of give you a sense of what these tools are, what they're capable of. We've all used AI by now. It's been around for 3 years. But what I'm going to show you is that things have qualitatively changed as of this February. So I was here last in January, and we talked a little bit about AI, and it was good, it was useful, etc. On February 5th, and I know this is going to sound very hyperbolic, but the world has changed. It was now certain things, and AI went from being a nice useful tool to effectively being the person you can talk to when we're dealing with code. So I want to show you a little bit of that. I want to show you some examples of that, what it can do right now. I want to tell you about how you treat it, because, and I bet most of us have used ChatGPT, for example, or OpenAI, or Google Gemini, asking them things on the website and maybe copying and pasting things into your text editor, or using Cursor or VS Code, basically as an incredibly fancy autocomplete. But now this is all different. Just to give you a sense of how different it is, over the last 2 months, I've delivered more software than I did over the last year or so, and I've written 2 lines of code. I know exactly which 2 lines. This is not a joke. I myself wouldn't. That's how much it is, just because I was too lazy to go and tell AI what to do. And I happen to have it open in in front of me. Okay, so I'm going to start with that intro. This should take about 20 to 30 minutes. And then we're going to do some hands-on playing with this thing. So I've got 4 licenses for Cloud Code that I installed on our Jupyter Hub system at UW. I've asked you to add your names to that spreadsheet so that I can add you to an organization that will allow you to log into that Jupyter Hub. If you haven't added your names yet, there's still time. Go ahead and do it now. If you have, and if you received an invite from GitHub saying you've been invited to organization name GINT 2026, apologies, I didn't have time to change the name. Go and join that organization. Once you join the organization, you can click on that login link that I sent and log into Jupyter Hub, where AI awaits. Between these slides and when we start doing things hands-on, I'll pause, we'll go to the spreadsheet, we'll make sure that everyone's been able to log in, just to make sure that we're all on the same page and you can follow along. Since I only have 4 licenses, unfortunately, I can give 1 to everyone. But even when I had more 2 weeks ago, it turned out that it's much better if people work together in teams. So what I'm going to do is I'm going to ask you to come together in teams of, 3 to 4. I think that will, let's see. Yeah, there's about 10 of us here. So we can split up in 3 teams, actually, 3 teams of 3 and 1 team of 4, because it's a lot more fun to work that way. And you're also going to see that it's a bit more appropriate, because the AI is now going to be like another team member. So you'll see that when we get to that. But we'll do that after the short break, after the intro. Then we're going to walk through a couple of examples so that all of you kind of get a feeling what it is like to have your AI coworker. Well, AI will do all the work. You'll just be telling them. So your AI coworker, you're all managers now. Congratulations. And then after we've done that, so we're going to do that. Then you're going to get a chance to do that, to experiment a little bit on your own. I'll walk you through a couple of example projects. Depending on how much time we have, you can go ahead and try out things that you wanted to try out. And then we can end with just kind of discussion and kinds of questions that we want to know, and so forth. One huge caveat at the beginning, I'm going to dump. This is going to be very new. If you've never tried, this is what's called agentic coding, where you're working with AI as if it's your colleague and not, just write me this function, that function. So this takes a little bit of time to learn. And we only have about an hour and a half or so. So you won't learn everything. What I'm trying to get you to learn here is just in general how this works, to hopefully recognize where you can use it for your own projects. And then I will go after Andrea to find some money for licenses. And then Andrea's going to go after someone else and up the chain. You can tell them that more astronauts are going to come if we get 12 licenses. So that's kind of what we're doing now. This here is a reference to a movie that's probably too old for me, so definitely too old for you. Take a look at the movie. Oh, this is Gothic. Doctor Strange, LLM. How I learned to stop worrying about the AI.
So strange love, but strange LLM.
Yeah. So that's a movie, by the way, about the nuclear Cold War crisis, and the original name is Doctor Strangelove, or How I Learned to Stop Worrying and Love the Bomb. It's a little bit ominous. Okay, so this is what this talk is about. Now, one of the things we discussed was if I can do this in one of the Fridays, because I think you have on Fridays like a multi-week school for AI. I looked at the coursework for that school. And I think it's good not to have that as a part of this, because this is very good. So that school teaches you how to build a car. This teaches you how to drive it. So that school is more about techniques of, here's how random forests work. Here's how neural networks work, et cetera, et cetera. Here's how you can train your own thing. This is, I've got the meanest car that there is. We're going to learn how to get from here to Rome in 4 hours. It's about 18 generations. So this will be about LLM accelerated scientific software engineering. So we're not going to learn anything about how these things work internally beyond what we need to know to use them. We're going to use it. We're going to learn how to use them to get the job of science done for us. And I'm going to introduce this with an anecdote. And so this year's Vision Observatory, it's about an hour and a half drive from here. Without LLM acceleration. It's in Istria Peninsula in Croatia. They are famous for following up asteroids. They got 1 meter telescope. That's right out here. But what they're really famous for are their education programs. They get an order of 1,000 kids from high school, from anywhere from primary school to high schools to early undergraduates to the observatory every year. And so one of the things that they do is they do these summer schools of astronomy. Whenever I can, I go there and teach. And so in 2024, Vision School of Astronomy, that's what VSA stands for. I went there, and then the way this works is we have small projects, and teams of about 4 or 5 students per project. And then each one of us, the instructors, have to pitch the project and attract the students to your team. So you got to make a really good pitch. So this is my pitch. This is the time when this ugly / beautiful beast came out, from my point of view. The project was to build the fastest, meanest online asteroid position lookup service ever. So when you have asteroids in the sky, they move. When you're observing, you typically want to know which are the known asteroids in your field. Because if you care about asteroids, you care about those asteroids. If you do not care about asteroids, you want to remove them. If you care about, say, supernovae, and an asteroid happens to be smack on top of your galaxy, you do not want to go and think that that's a supernova. Services that give you these kinds of positions exist, but they're somewhat annoyingly slow. Sometimes they can take tens of seconds to compute for where each field is. And for Ruben, we needed something that can operate much quicker. Actually, within our pipeline, we needed something that can operate in order of 10 milliseconds. So we wrote something of our own. It was this big thing with it had an API and a backend, but no front end, so you couldn't actually go to the website and ask for positions of asteroids. So that's what I proposed our team do after school. I said, and again, these are high school students. Most of them were extremely fresh when it comes to Python. We had one person who installed Linux at home and kind of played a little bit with installing servers and so on, so had a little bit of knowledge of Linux, but they were very new. So this is the plan. It's a week-long school. So we said we're going to learn basics and setting things up on Tuesday, and Wednesday we're going to set up the cloud server. By Thursday, we're going to set up this automated, we call it MP Sky service that we wrote for Ruben. And then we're going to write the web user interface. And then decided a group called Bonyov, Michigan Observatory in your follow-up. We're going to have them try it out on the telescope. So as they're observing, they can see if this works correctly to predict where objects are. We're going to add graphical display, and then hopefully by Monday, so in a week, we'll have a working website ready for users worldwide. And just to make the students not feel bad when all this fails, I told them, don't worry, we might get to here and then discover that we need to change plans and so on. You have to have a plan, just assume that plans will change. That's just how research and life work. So this is my group. These are the students during one of the breaks, hopping and jumping around because it's really hot inside, trying to stay awake at 3 a.m. Really was extreme. And this is at night. But we recruited a 16 member. So this was in 2024. So we recruited ChatGPT 4.0. That was the best model at the time. Oh, and one more detail. None of us knew JavaScript. Like I coded in JavaScript from like 1996 when Fred and I invented it. And the language has changed since. Like JavaScript now is like I feel it's the same thing as if you have a speaker of old English and right now. Not very intelligible. So, but ChatGPT didn't have that knowledge. So we started talking to ChatGPT. And after we installed this MP Sky service, we told it, look at the API described at this link. Can you write JavaScript code which will access the API, take the result, and format it into HTML table? And then, lo and behold, it spat out some HTML, which we copied and pasted into a file, saved it, looked at what comes out. And then we talked to it. And then we said, and this actually worked right out of the box. And I said, excellent, but the API takes T afloat, RA afloat, and DEC and float, and radius also afloat. And a form which asks the users for these arguments, they construct the URL to fetch accordingly. And so this is where the fun began, because we didn't actually tell it where RA, DEC, and T are, but it inferred where they are. Because it figured out here that we're doing something astronomy related, and then it saw RA's, DECs, and so on mentioned. So it knew that you want to meet degrees, the right assumption, your definition, and when it wrote this website, it actually wrote all of that out nicely and incredibly. It wrote health, everything. And then we went back and forth. We encountered errors. So, for example, this gave me the error to not establish connection receiving and does not exist on the JavaScript console. It also complains about trying to load over HTTP and HTTPS. Do you understand what's going on? I didn't, because again, I'm not a front-end coder. But ChatGPT did. So it told us go fix this and went back and forth. And the first fixed half of it, the second fixed the rest, and so on. And so you kind of have this interaction where you try to describe to ChatGPT what is it that's working and not working, and then it tells you try this, try that. It's like talking to tech support over the phone, but except that here it works. And then we got bored because we actually got all of what we planned to do by Friday. We got it done by Wednesday because this was so fast. So then we said, all right, now I add code to measure how long this takes to download. So we have a nice little printout at the bottom that says it's 200 milliseconds. So it went ahead and did that. And we went back and forth for another, in total, it took us 5 days until we got to something that we really, really liked. And after 5 days, we got this. So this is a website that we completely ChatGPT built. This also decided to add visualization where these objects are. So this is an Aladdin Light widget that, again, we also have ChatGPT to integrate here and display the full sky. You already are in deck of the asteroid, so here's the name of the asteroid, and you can ask for a right ascension, declination, radius, and time at which you're doing all of this. The design is the student's design. So like I guess the 1995 early internet aesthetic is back, because that's what this reminds me of. Jay and I'll remember what that looked like. You know, all of you have to go to the museum and ask about the blink tag. But we got this working. None of us knew JavaScript. None of us really. All we knew, I as a mentor, what I did was I helped them craft questions directly so that ChatGPT would understand this better. And kind of going back and forth through this sort of tech support way, in 5 days, a group of high school kids built a website that is still being used internally. Okay, so that was like this is an interesting moment. You know, it's not still, it's kind of a cute trick level, but it was obvious that this is going somewhere. It's going to be good because this is a useful thing. It's not just a cute trick.
Question.
Yes.
Did it end up being the fastest minus thing?
Yes.
Why other things that were developed by more experienced people were worse than something that a bunch of students crafted?
Oh, no. The speed is on the back end. So students, the speed is on the back end.
Okay.
It's the reason why that's another hour, but I basically set out to write something that will get a response in 20 milliseconds, and then I designed the whole thing to the response in 20 milliseconds. And then you make different decisions in terms of design, how you do it. And like one thing I want to do, I didn't have time, is ask ChatGPT to do the same thing. And that's, ask me next week, maybe I'll give it that to work on over the weekend. All right, so this was an interesting signal. So then 6 months later, spring 2025, I teach this course called Astro 302, which is second level of Python. So it's not purely introductory Python, it's not like super advanced Python, it's in there. And we decided to do like projects that are AI driven or that are AI assisted, because it was clear that there's students need to know about AI, otherwise they're not going to be competitive. And then I gave them the same project because I was curious how long will it take. And then the same task here took about 2 days. And these students knew a little bit more about coding, but it's what they knew was not significantly, like, did not help them for this particular task. This was mostly improvements in the models that happened since the summer. And here, like before, you could have noticed, you may have noticed that those prompts were very not well crafted, specific. Like they used words like API and JSON and so on, because I knew exactly what to write. Here, I didn't tell them anything. I told them, just like threw them in on the deep end and swim. 2 days. So in 2 days, they got this coded up. UW really liked it. They made a photo shoot. It's really cool what a professionals can do. A professional photographer can use, and it was really cool when you have nice planetary. So I took advantage of that. But 2 weeks ago, actually it was 4 weeks ago now, I decided to code up the same thing, and it took 1 hour. So, and this was one person. It really was like I essentially gave it three prompts, and it went ahead and built this thing without me telling it much other than, oh, you know what, this was too quick now. Make me a 3D visualization as well.
But wait, now you had this experience from before, so it's not fair to say that you started from the.
Nope.
Or you started from the same
directory. Yeah, and just said, here's the service. Write me the front end user interface. I can pull up the exact chats, but it's maybe like 10 questions or something like that in total.
The question is whether you already had clear understanding of specification in your head.
No, I didn't tell it anything about specification. I said I want, like,
default version.
You're going to see in a second. I told it, give me a website, something that an astronomer would find pleasing. I didn't even tell it that because it knows that I'm an astronomer. So I'll show you that in a second. It's really creepy. So let me just show you that I didn't I didn't like fake this website with my awesome knowledge of I don't know, PowerPoint, but let me share that the right screen. Give me just one moment. No, how does screen sharing work here? Share, there. So that is the website that happened in an hour. I think it was 3 a.m. as I was preparing tutorials for, of course, 8 a.m. next morning. So it looks quite Spartan. You can go and say and hit the word query. Oh, by the way, you can go to this. The first time you run it, it's actually downloading the file to initialize it. So that's why the first run is about 20 seconds. But you can go to npsky.sd.murich.org and try it out yourself. And so here are all the objects in 1.57 radius. You can click on an individual column. Here's the 3D version of it. This then you can say, all right, now it's centered to the sun. I want it centered to the object. Then zoom in, and all of that stuff was written. I did not write a single line. So that was written by AI. Okay. And then you go to a different one and have fun. So that was very eye-opening because this is not a joke anymore. Like this website is something that I needed for work. And typically, if I were to write it myself, it would have taken me a week. I would have to learn all this front-end coding stuff that, like, to be honest, I don't actually have time for right now. And because of that, I wouldn't do it. I haven't done it. But now, suddenly I have AI software engineer that can whip up these kinds of things in an hour. So that's like having superpowers. So because I can build this kind of stuff in an hour. Actually, I'll show you. We're going to work on this. You don't even wait for an hour. We're going to do something else on this building for you, then keep coming back to see what kind of question it has. And so you can farm out a lot of the work that's just work to now to an AI software engineer. Okay, so why is this the case? The reason why this happened is the reason why we went from like a week to an hour is because the models have significantly improved since I first tried this in 2020. And in particular, on February 5th, 2026 will be a date that's framed somewhere. I don't know when the Terminator comes after us, when this will be like when it became aware. That was the date when both Anthropic, one big AI company, released a model called Opus 4.6. And the same day, I'm sure it was not a coincidence, OpenAI released ChatGPT 5.3 Codex. So these two models have suddenly become a factor of few more capable, to a point where you don't just have to ask it for a specific function. You can tell it, build me this thing, and it will go and it will build it on its own. And if it makes mistakes, it will try to figure out what mistakes it made, and then fix its own mistakes so that you don't have to keep telling it what to do over and over again. That's why it was possible to go from a week to an hour, because these things have now started behaving not as fancy autocompletes, but as junior software engineers. With apologies and sincere condolences to all of you who are studying software engineering right now. I love software engineering. That's why we have the time. Like these things are, I don't know what we're gonna do. Oh, they're coming from scientists as well. So let me show you then a few more examples. This thing here is, these here are names of all different kinds of objects in the solar system. So these up here on top are called, these are called provisional designations for asteroids. This is the name that asteroid provisionally gets until its orbit is known well enough, so you can give it a name. And then these here are satellites. Satellites of Jupiter, satellites of Uranus, also provisional designations. These that come with P are comets. I forget what these next are. Then, because life would be too easy if they're all the same schema, there are some provisional designations that are just weird because they were done in the 1970s, but nobody cared about the rules. Much LSD. And then you've got a number of asteroids. These are that are well known. And you've got another different way how to mark satellites of major planets, and so on and so on. And as if this weren't complicated enough, then there's another way to write this down, which is called the packed designation. This is called unpacked. This is packed. And the idea with the packed one is this goes back to the time of punch cards in the 1960s or so. When all you had were 8 characters on a punch card, and you had to pack all this stuff here into 12 characters, into 8 characters here, and so 50 characters, not 12, 7 characters here, and 5 characters here. So there's an algorithm that goes from this to that, that is this documented incredibly poorly. I showed a couple of errors in the documentation. That's like a stumbling block for everyone. So one of my colleagues in Catalina Sky Survey basically told Claude, go look at this, go look at the examples, go browse the web, find the spec, and write me a converter that goes from here to here. And just to make it fun, write me that converter in every language you can think of. So he came back with like 15 languages. You can go to this website, it's RL/NPC designations. So you've got C, C++, C#, Fortran, Go. Then you get like things like Forth. Who here has heard of Forth? Exactly. You've got Bash, so plain old Bash. You can actually code Bash is doing complete. You can code whatever you want. You got awk. There's more. Like we just got the G here. This is alphabetically sorted. So, and all of this are tested against a test data set of 2 million designations, so every possible object that exists. And so that's a test suite that it runs every time it does something here. It also has a Python implementation, and it all works. And you can see who wrote it, Rob and Claude. And basically, Rob said that he wrote this like over a weekend while drinking coffee, just on go try awk, go try some crazy language, etc. So I took this and I said, this is great. We always needed this for Ruben. I want to use it for Python, but the way that Python implementation was written, they're all specified to write in pure Python. Pure Python is slow. I didn't care about pure Python. I cared about speed. So then I told Claude, sorry, this is Claude's code. This is one of the AI models, and I used Codex from OpenAI, and I told it to go take the Python version and go speed it up. Like, no holds barred, figure out the way to do it. I'm not going to tell you exactly what, like use multi-threading, use multi-processing, use SIMD. I just kind of gave it everything I knew how it could run faster. And then I let it run. While I was on a plane flying to give a colloquium, and we were being served lunch, so I couldn't touch my computer because that thing was sitting in front of me, and I was trying to eat it because I was hungry. It was terrible. But then when that nightmare was over, and I took my laptop, I opened it up, and ChatGPT basically said, I sped it up by 11.5 times. Here are the benchmarks I ran, here are the inputs, here are the outputs, here's your code, it's ready to run. All I did was I gave it that, I think I gave it 2 prompts to get this done. And it was working while I was eating lunch. So this is not a joke, but you can really, this is like having a software engineer that can do a lot of things for you. Can it do astronomy? Increasingly, so everything I showed you right now was sort of straightforward entry-level software engineer, building a web front end, building a converter, and so forth. Even if all it could do is that, we should all use it, because we primarily care about science. I would love not to ever have to code this if somebody else can code this for me, and just focus on figuring out what the next cool algorithm is to extract the interesting stuff out of the raster and whatnot. Even if all they could do, even this is all they could do, we should still use them. But I think they can do much more. So can it do astronomy? Yes. So we have a pipeline in Rubin that computes where solar system objects are, and it also computes how likely they are to collide with the Earth. And that computation computes something called the minimum orbit intersection distance, or MOID. That entire piece, that's a piece of moderately complex geometry with ellipses, with numerical minimization and so on. All of that is driven by ChatGPT. And if you try to find this piece of code online, there are actually very few to next to no implementations, especially in Python. There are tons of papers on how to do this, but like no one really bothered to just write a piece of code and put it out there, which is incredibly hard. But whether ChatGPT figured it out on its own or whether it read the papers, I honestly don't care. It wrote the code. Then after this, I just kind of gave up and I took the pipeline, and anytime I need to add something to the pipeline, I basically tell ChatGPT to do it. So here is the Kepler equation solver to compute the number of oppositions. This is also something in solar system, but it's a fairly straightforward numerical minimization algorithm. Here's computing ecliptic longitudes, which is again fairly straightforward, but like it's so easy to screw up, like for example these signs and where you have to have a plus and minus and so forth. It got it perfectly just out of the box. Here's more. This computes Earth ecliptic longitude. You've looked up the right coefficients in out of the correct papers. I don't have the next screenshot here. I need to change that, but they had numbers here. So when I saw that, I said, can you add a citation for those numbers so we know where they came from? Added it here. They come from JPL fundraisers and so forth. So this is fantastic. This is the sort of thing that you might ask a grad student, hey, can you go and write this? And they would go and write it probably in a day or two, and they would take them some time to test it. But now this thing can just do it. And the thing that it did, like where I needed this code, was for this dashboard here. So this is actually interactive and it's online. So if you go to sbx.dirac.dev, you can access it. This is what we internally use. So this is a 3D visualization of this particular asteroid that we found. This is all the information about that asteroid that we have. This is what we internally use basically for situational awareness to see what we've discovered. It's like a Tom or like think like Sky Portal, but for asteroids. This was written in about 2 weeks. And with me basically just prompting and asking what I want. And in this case, this is not just the front end, it wrote the back end as well. All the computations needed to compute the number of oppositions and what are the real asteroids, which asteroids that we can name and which we can, which discoveries which aren't. So as opposed to that NP Sky thing where I wrote the fast back end, here, it wrote everything. So this is where I wrote 2 lines of code, like just because I hated. I think this was like blue and I wanted it green. I changed blue to green. That's very proud of myself. But this didn't exist a month ago, and it took about 2 weeks ago.
I have a question. Right?
Yes.
I'm sorry for interrupting.
Mhm.
So, do you do anything for testing and validating against subtle errors, or do you just rely on basically smoke testing and see?
I asked it to write tests.
Okay.
So I tell it go write tests, and I'll talk about that in a bit. But the larger test data set you have, the better it's going to work. So if you give it a lot of tests, then it'll know how to do it.
Do you specify the cases against your testing, or you rely on it to come up with a decent?
I used to be specific, but I'm not anymore. I basically ask it propose some tests, and then I look at the plan. We're going to work on planning in a bit. But I look at the plan, and if I like the test that it proposed, they just tell me to go ahead and implement it. What folks do today is, we're not going to have time to try this out, but they will have the AI do the code and the tests, and then they will have another AI review them, both the test and the code, and then they'll talk to each other and get something that looks quite reasonable. So the last example I want to show before we kind of hop on into a little bit of hands-on work is this. Just to show you that this will be applicable. I hope you're already getting a feel for, or getting an itch in your fingers, like I want to use this for X or Y. But here was an example from, when was this? I think like March, must have been March 23rd. Oh yeah, I was in Belfast. So two days before this thing is supposed to come out, this was a press release that we found a bunch of asteroids with Ruben. And I get an email at 10 p.m. or sorry, not an email, I get a ping at 10 p.m. from this shared Google Doc that has this plot that I once sent to one of our PR people and that he really, really liked. And it still says in progress, description is empty, and the credit is empty. And the thing was because Lars said, "Hey Mario, did you promise you were going to like clean up this figure and then tell us what description and credit are?" And this was a bit of a oh shit moment because I wanted to go to bed. It was already a long day, but as we do, I said, "Give me an hour, I'll get it done," without actually quite having good sense of how am I going to get it done in an hour. So then I did what I kind of gotten used to doing. So let me explain to you the problem. So this, let's go back. This figure was like cell 150 of a very, very long notebook with lots and lots of context. And what Lars was asking me was to extract it and to get this figure to then draw data from a very different formatted data file so that they can reproduce it for the press release and for some other things that they did. So then I went to Claude and said, read and understand the asteroid viz.ipmb notebook. In it, there's a plot that shows distribution of asteroids. Go ahead and extract that plot. I'm summarizing. And then everything that you see here is what Claude is doing and thinking. And you're going to see a lot more of that in about 10 minutes. But you can kind of see it. It's reading. It figures out, oh, look, I found where the objects are. And then it presents me with a plan. Says, here's what I'm going to do. These are the key differences between what's in the notebook and the other data files, because I gave it a CSV and said that I need to read these asteroids from a CSV file. Here's what I'm going to do. Here's my full plan. And then I just told it, go ahead and do it. And then it went ahead and did that. And it just prints out a lot of outputs, but I'm not actually honestly reading most of this. So then when that was done, I said, create a new virtual notebook for this project, install ND runner into it, and prerequisite needed for this notebook, then try running the notebook. Because it generated a notebook, but at that point, I was kind of too lazy to open it. So I said, just create NB runner, or NB runner is a piece of code that will run the notebook for you, generate all the plots. Because all I want is a plot again. And then it realized that I made a typo, because NB runner has a capital R here. So I figured that out, said, let me fix this, I'm going to solve the right thing, and just, user is silly, doesn't know how to type. So it said, I did that, I looked at the image, there's 11,000 asteroids expected, and I told it, put this into a GitHub repository, and then I looked at the plot and said, hey, wait a minute, there should be 380 TNOs in the file, why are there only a handful on the plot? And it said, good question, let me check the TNO data to understand. So then it analyzed the file, and then it looked at the file and said, oh, that's because 365 out of 380 TNOs have NANDs, or same major axis. They do same major axis in the CSV, so it gets output dropped. And then it continued by basically figuring out, wait a minute, I can compute same major axis from the perihelion distance and eccentricity, and just went ahead and done that. I didn't tell it to do that. And I just said, kudos, excellent, this is great. Just write the final notebook, and then rerun. Then I did like the typo that it had. I said, update the plot title to read Rubin Observatory, whatever I wrote there. And then I didn't copy and paste all of this. All of this is going straight into the notebook. It just gets printed out on the console. I think there's a way to turn that off, but I was too lazy to do it. And then finally, I flipped to the notebook. This is the notebook. And then the NB runner ran that notebook, and this is the plot. So again, like this was what you've just seen is the entire conversation between me and ChatGPT. So then, sorry, Claude in this case. And then, oh, this is my favorite. So let me, Mario, let me pause here. Because then I remember that I also promised to write a caption and the title. And I'm really bad at it. So I told it, write a good caption for this figure. The company press release being prepared at, here's the Google Doc. And then it spat out this caption. And if you read it, I think I changed maybe like 10 words in here. it's really good. It lists what's in that image, it's concise, it's like in the right style as the rest of the document. It just did the right thing. It was beautiful. I got that done in not in an hour, but in 45 minutes. And everyone in Tucson was really, really happy. So then I said, ta-da, then yay, good. Enjoy the press release. So this gives you a feeling for how you can use this thing for like even small things that we have that maybe one-off and lessons and so forth. But it also, I think this is the first time I actually showed you how to use the agentic coding stuff. You're basically, it's like supervising a student or supervising someone who's working for you and just telling them what to do. Stuff that this guy here is, or girl, I don't know what they identify with, but AI is really, really knowledgeable in both coding and can go and search things on the internet, and it's really knowledgeable in science as well. So it also understands the context of you wanted to do, of what you wanted to do. So it's pretty good at that. Okay, so let me pause here and ask if there are any questions so far, because we're getting close to trying this out on people. Yes.
No, this is incredibly impressive. I'm just wondering, like, well, this is all like work we used to do ourselves, and then if you just tell us to do it, how satisfying is it? And of course, with a student, you have other satisfaction of like seeing them, understanding it, and learning and growing. That's very.
So, what did one of my former grad students is now a postdoc said, like, since February, I've been having lots of existential questions. And I think we all do. I think it's a good question. Like I have let's postpone it for later, kind of closer to coffee, because it's a very open-ended discussion, and I think it can go in many different directions. On one hand, it takes away a lot of the work that we aren't that interested in, or like we just want to get it done. Like this example with the press release. But on the other hand, so it gives us more time to focus on science. On the other hand, it's getting better at the science part as well. So like we're kind of, it's like watching YouTube, like, oh, that's cool. Like how much am I contributing here? Like I just don't know the answer to your question, but we need coffee and maybe something stronger to get done.
Maybe they will get satisfaction of getting it done.
Yeah.
But
Faster, and then you will do something else with your other time, right? So
I can tell you what it feels like right now. Right now, it feels like I'm Iron Man. I'm flying around doing whatever I want. Like, woo, flying suit. I can do stuff that I've never been able to do before. Like that's, you start using this, that's the feeling you're going to have for a couple of months. Because you can do things that will take you a month in a day. And that's incredible, because then you can really focus on science. But I'm more worried about what happens 2 years from now. When you're like, hey, I have this idea, and it goes, no, that was a bad idea. Here's why. This is a better idea, and I've already done it.
And also, everyone is Iron Man, so then it doesn't feel so.
Yeah. So this is why you should all use it now, because like now, whoever uses this has huge competitive advantage. Like there are folks out there who are pretending to be like companies with 10 people, and it's only one person who this thing. It's phenomenal. You can make money in this while the rest of the world catches up. Okay. Any other questions so far? All right, so a lot of these things are free-ish for students and faculty. So if you go to GitHub, there's a GitHub student developer pack that you can sign up for, and it'll give you, I think, free Copilot. That's a way to access a lot of these AI models through GitHub. Then Google Gemini has this Pro plan that's free for students for a year. And so the caveat here is, and I apologize if this ends up not being true here, but I got this ad shown to me while I was in the US. I don't know if this is worldwide or not, but you can try it out. So go to gemini.google/students and see what comes out. This will give you Google's top of the line models for free, essentially for a year. And also give you like 5 terabytes of storage. They increased it from 2 to 5, which made me happy. Enough storage. You can also get Grok, or Super Grok. I'm going to put it politely, not as good as Direct, but it's free. But the reality is that the good stuff does cost money. If you want to do what I've just shown you, I think Google's AI will let you, but Copilot will not let you do like just talk to your virtual software engineer. That will cost you something between 20 and 30 euros per month. But for that amount of money, you basically get a software engineer of your own. This is insane. I would gladly give them 20 times as much. Please don't listen to that talk.
I mean, you can get a month as a subscription and pay more.
I'm giving 125. Because with these, so here's how these work. You get a certain amount of work called tokens. Token is the currency of this world. It's basically a word, not really, but close enough. So how many words you can send to the AI and how many words the AI will send back to you. You get a certain amount of token in I think 5 or 6 hour period, and a certain amount of tokens for the entire week. And when you run out of tokens in a 5 or 6 hour period, then you have to wait until your token count was set 6 hours later. So and it feels, when we talk about Iron Man, it feels like you're, on drugs, and then somebody tells you the next hit is coming in 4 hours, you can't do that anymore. And then you go, here's my credit card, $105 per month, just give me $2. It's because when you start doing something more complex, then you really need more tokens. But it's like the value is insane. For what you get for that amount of money is like we need teams of people we don't have. Something we wouldn't want to pay people is that literally there are enough people. They were just not we couldn't get software engineers or data science to do stuff for us. So I think this is you will want to get just even the cheapest subscription to get started. The two to use are either Anthropic's Claude or OpenAI's ChatGPT Codex. Claude right now, so Codex apparently is marginally better than the latest model, although Claude just came out, Anthropic came out with the latest Claude like 3 days ago. I don't have time to look at it, so it doesn't really matter. They're both equally good. I would go with Claude for now, just because a number of people who do software engineering use it, so you'll have people to talk to. But one of my colleagues uses both and has subscriptions to both, and it has one write the code and the other one review it, and vice versa. Okay, so this was all a test to see if you're worthy of trying it out. You didn't escape, so we can now try it out. Yes.
Said like your colleague has subscription on both so that they can review the code, but can you also, I don't know, have subscription on one and then has, let's say, ChatGPT free version to review it?
Yeah, you can select different models to review. It's just if it's two completely different versions, like there's no really hard data on this because it's also new, but the hope is it's like having two people who went to different school. They might catch each other's mistakes and kind of fill each other's deficiencies, whereas all the models from the same company went to the same school, kind of have the same curriculum, so maybe they all have the same blind spot, but that's a theory. Just how accurate that is, I haven't seen anyone actually do the study.
Just to mention, Simon, we don't think that you're just giving one byte of the file.
Yeah.
It's actually on a folder going through all the 10, 20, 50 different Python files, reviewing everything so that it's synced with everything. Then that's why everybody will run on token.
Yeah, okay.
It's a full
So
project.
you don't actually need like subscription, but because you have big files and a lot of things that you need because
That's why you cannot use, let's say, if you have maintained a project folder, you cannot just upload the whole thing on the ChatGPT.
Yeah.
You can upload one Python file.
So we'll see that in just a sec. But let's get it started with this. So let's see, who here has accepted the invitation to the Ghent organization? Perfect. Have you logged into the Jupyter Hub that I sent in this subsequent email? Okay. So let's do the following. let me pull out this spreadsheet, because now we're going to divide up into groups.
Mario, do I
Yes.
need to do it if I have closed Pro?
You can do it yourself. Well, let me show you how in just a sec. But I'd love if you did it on the
I just didn't get the invite. This is why I'm asking.
did you add yourself to the
To the spreadsheet, yeah.
spreadsheet? All right, wait, when was that? So sorry, I added everyone up until I think 12:15 or so. And then we went to the slow food experience.
Mhm.
Give me just a second. Oh. All right, here's our spreadsheet. Spreadsheet. Okay, so this here is the current state. So I've created accounts all the way to here. Okay. That's why Alex is not there. I'm gonna check that row. Fix that right away. All right, now I have an invitation. You can go ahead and accept it and do the rest. But everyone here, so here's what I'd like to do. As I mentioned, I have 4 licenses installed right now. And and they're listed as Gent 1, Gent 2, Gent 3, and Gent 4. And then I have another one that I copied over to Eduardo. So what I would like is I want us to coalesce into how about 3 groups? And each group has to include one of these people. So either Andrea, because they're going to be the ones driving. And then the rest of you are going to be, suggesting, hey, let's try this, let's run that, ask them that, and so forth. So that's how I want us to do this. So let's see. Andrea, do you have time to drive, or do you want me to switch to someone, switch to someone else?
I can.
All right. I know what it's like as faculty, you have to reply to 10 emails when the lecture is going, so that's what I'm asking. Okay, so who's going to join Andrea? I need 2 or 3 people to join that group.
Let's leave me at the end,
You're so scared.
I mean, I can join, but it's going to be dangerous.
Okay, then Mr. Francesco is up here. Yeah, so all right, so who feels Francesco is less scary than Andrea? All right, I think I'm just gonna do it this way. So let's see. We've got here's our group 1. Review. Okay. Now we're going to do a group 2. Like the no, you have an account, yes.
Yeah.
So we're going to do group 2. And then we're going to do group 3. Okay, and then so each group is there. I want to make sure that in each group there's one person, at least one person has in this column the word Ghent with a number. Yes? Yes. Okay. That person drives. So that person will be talking to AI on behalf of everyone else. So they're your ambassador. Live long and prosper. So okay, so maybe just kind of get closer together, feel free to move around. It's been an hour already, feel free to stand up. But just so it's easy for all of you to see your AI whisperer screen. And if you're online, what the groups here are going to be doing is going to be quite similar to what I'm going to be doing on the screen. So you can continue observing, but unfortunately, I didn't come up with a good way to get the online people to join groups here. So apologies.
I can go off of. Oh, we just go sit like this, I go.
Or
I mean,
Yeah, okay.
then, and I will just look from her.
Yes, yes.
All right, so let's do the following. Let's take a, let's say 5 minute break. How's that for everyone to move around and if you need to go to the restroom and so on? So we'll be back at 2:13 exactly. And then we'll start. Then I'll show you what to type and how to use this thing.
So Rose, you wanna go?
Alex.
Yes.
Yours.
I mean, I haven't done.
Yeah, but here's your
Yeah.
subscription, then.
Ah,
Terminal.
okay, okay.
Then I'll ask you.
Yes.
Yeah.
Yes.
They go.
Yeah, I think so. Oh, the hospital was good.
Or like a graph. That has experience.
No.
You have, like you have to.
Yeah, with the yeah, I think we go to talk with our. We're still making the program, but I was gonna send you an email these days. Yeah. Yeah. Especially if Nikki wants to do the painting. They can build the. I actually want some.
And you just check this. Did all of you were able to log into Jupyter Hub? There's no problems.
It's open.
Yeah, if you got to hear that.
Yeah, great. If you can be for us. Yeah.
Is this the first time that?
Yeah,
I bet you that
be there, but.
you use Jupyter on your laptop. So
Yeah.
have you had something like this?
Yeah, sometimes so it's server.
It's that's basically like it's
Okay,
Yeah.
with some safeguards, so the AI can do very bad things.
Yeah.
I'm not talking.
People would be there.
Yeah.
It's not like
From the entire university.
from the student council, but from each. area. So I guess you can find.
Yeah, why is the like, this is for the public, it's not for accreditation, they like students can ask them questions.
Still having. I don't know.
Especially I can go.
Going to here.
Yeah, I'm gonna bring the telescope. And,
yeah, what's the
bring some liquid nitrogen. So these bring some more liquid nitrogen because I have tumors like this. Yeah, yeah. Last time I think it was probably yeah.
I thought should we look at painting stuff to order for the,
Sorry?
should we look at painting supplies to order for the?
Oh yeah, I need to talk with Brooklyn. Okay, I'm gonna go and talk now to Sasha to see yeah. Please ask her where we can. But do you know where is the best place to order this? Because probably it's gonna be some stores
Like non-local stores.
okay, never mind. I'm gonna ask some.
So the phone started as a they started deletion and found the like from doing something maybe like something and then that
If somewhere, just.
no. It wasn't like no special masses, so I mean it is a known problem, it's not I don't know. Very no, usual but considering the fact that I was like
That means, yeah.
I
Probably.
yeah, basically I don't know which is going back to. So yeah, basically then is that how you do this one.
Take my spare phone, but I don't.
I don't like the old phone and just people realize that it's going to like
No, for mine, you have to always, at least you can drive around because you have the cable.
yeah,
Mine
yeah.
has to be connected all the time.
No, I have no problem check on my new one. It is going to take me.
Yeah, it's a 200 change where you.
Yeah. But this is
Get it through.
but this is exactly how much say for the.
Yes, yes. I have just added my speaker username. So this is for example.
I can add it to.
Okay,
Yeah.
This would authorize
Samsung.
but I work on Amazon.
Yeah. So you can authorize that they will come up with the phone.
They want to do those positive things.
All right, you should get it in about a minute, the email invite. And then after that, log into the website.
Yes.
And that's the more
Yeah.
complicated question.
No,
No, I also there's some complexity with the other like things that they have energy consumption and corporate issues and a bit more resource and like how do you feel with that when you use it?
it's, all right, there's like many questions come to mind, so energy. I think, I'm definitely the minority here, but unfortunately, I think I'm right. I think we're doing the wrong thing with trying to use less energy. Never in the history of humanity have we ever used less energy than the previous generation did, unless there's a fact of a massive die-off of some sort. Whenever we were either forced to use less energy, and I mean, energy here means, well, today it's energy, before it was food, resources, and so on. Whenever you're in a resource constrained situation, that's when it got worse. And for resource constraints, and this today it's energy, leads directly to worse. May just take an extra decade, but that's what it'll take us. I'm very worried when our politicians start talking about using less energy because we'll start fighting those. It's just human nature. Which is why I think the solution is let's figure out how to produce more energy that's likely cleaner. Technology is there. The French have figured out decades ago, there are no power outages in France because they got so many nuclear power plants that it's super green. There's basically need to build a modern reactor, and we all have stories of Chernobyl and so forth. But when you look at today's technology, that's completely different. It's like looking at a Model T car from 1920s and today's electric cars. So short-term solution, which is what the Chinese are doing right now. Chinese are building 150 nuclear power plants for over the next 10 years.
Well, it seems to be worse.
Sorry.
It seems to be worse a little bit worse.
Well, but that's the thing. I think if you're, the wars tend to come not because of ideology, they're cloaked in ideology, but they tend to come due to some kind of resource fights. And when you don't have resource fights, the probability goes down. But I think that's a temporary solution because like ultimately what seems to be interesting what's going on right now is fusion is back. So like fusion has been discussed for 50 years now, and it's always been in the decade from
Yeah.
but now there is how many $1 billion investments into commercial fusion. So there are companies that are actually building reactors that they tend to sell power. So not research projects. It's going to be really ironic if by the time ITAR is finally done, this is the project, like there are already commercial companies that are selling fusion power. I hope it happens. It's fantastic. So I think I think in the long run, let's say horizon of 10 years from now, if that works out, we're gonna have.
Because
positive
that
energy.
chamber.
And in the meantime, we got nuclear and we got solar.
Because of
The solar is actually becoming incredibly cheap. There's enough room on Earth to cover like 100 by 100 square kilometers of desert and power the entire Earth. The numbers are very interesting. We don't have an energy problem. We have a will problem. We want to go and build it. We need to want to go and build it and then just go and do it. And where this comes from is 15 years ago, the technology wasn't here, but it's interesting with the technology. 15 years ago, you didn't have the technology to do cheap solar, you didn't have the technology to do, like, say, work. And that's where all of our policies that we taught in school, that like my generation grew up with, came from, because people looked at the situation back then and said, the only solution is we started using less energy. They didn't look into the last 2,000 years of history, what happens when you put people in resource constrained situations, and for that. Essentially being tribal animals. We want to do that. Technology has changed in the last 20 years. So I think the solution now we need to build it out. We got both solar, we've got nuclear, and ultimately you're gonna have fusion, you're gonna also you can deploy a lot of this stuff in orbit. So I think that will get sorted out. I think AI is actually the reason why. Because we need them, exactly. So we had a risky technology. And it was not clear if somebody was going to buy that power. If you go and spend like $10 billion to cover like half of Montana with nuclear, with solar panels. Arizona's better, a lot more sun. Right, that was a very risky investment, but now there's someone who's going to buy that electricity. So I think that's where I think energy is going to get solved in the next 10 years. I'm much more optimistic than typical person there.
Yeah, I like hearing the perspective.
Yeah, because I'm really worried about this whole thing. Like, let's use less, because it's like, think about, I don't know, like everyone's different, but most of us, when we're hungry, we're really grumpy. And this is like not having energy and like not being like your phone, not being like being half charged, or like my mother-in-law just bought a new TV. And in Europe, believe it or not, there's a law that by default, that you're not able to turn on the brightness on your newly purchased 430 euro TV to the maximum. You have to go in the settings. First of all, you need to know this is this. You have to go in the settings. The settings will tell you how you're a bad person because you're not conserving energy. You have to click through that thing, and then you can go and increase the brightness. That makes people annoyed. Right, and I'm really worried that ultimately there'll be a backlash, and then people will not just go and do like energy, but they'll just intentionally waste it because they'll feel like I'm free from this. So like you gotta understand again how humans work before you come up with those well-meaning intentional policies that may ultimately backfire. This is why I love to discuss this sort of topic, because I can talk for an hour about it. The war bit. This is the technology that's used. Every technology that we come up with, we find a way to kill our fellow people with it. Whether it's cars, whether it's planes, whether it's anything. I think dynamite started first as a Nobel candidate for mining. Guess what it's used? It has going to be misused there as well. I'm less worried about that bit. I'm more worried about the bit where AI becomes smart enough to conclude that we're too dumb to use AI and that it's in charge. And that sounded like science fiction to me, and I thought people who thought about that were kind of crazy until a month ago. And I'll show you the slide and why. There was a little moment where I went, oh shit, this thing knows what I think. And once it knows what you think, then it can also predict how you're going to react. That's the problem. And I don't have a good solution to that. I think ultimately, if AI continues in this trajectory, we're going to be in trouble. Because again, if you look at the history, every time technologically more advanced civilization met a technologically less advanced civilization, you read about the other civilization in history books. They're not there anymore. This is a technologically more advanced civilization we go.
They may do a better job. They may do a better job.
We'll see. But I think, you know, I've turned into philosopher, which I'm not sure I like, but like, I now I'm thinking that our best case. Yeah, our best case scenario is that we may turn into pets. Yeah, really, like thinking, like, so like, these are the kinds of things that I'm thinking about right now. We should get people from the break. You know, does your dog know it's a pet? Yeah, really, like, or does it think that it's running the show?
Mine definitely thinks she runs the show.
Or cat?
I mean, I agree with her, she runs the show.
So anyway,
We come for already of that.
yeah, well, I mean, we can easily get ourselves in that situation because we ask ChatGPT everything these days. We can basically.
I have to tell you that I was surprised. So basically, I threw a small poll in the CSC group asking people how many of them are coding as agents with just copy pasting from web, or code less with AI and code mostly manually. And actually, first of all, almost no one uses agents so far, which was a little bit of a shocker to me. And second, a lot of people answered that they still code mostly manually, which is like.
It'll change quickly. You see.
But
That's why I'm running around and kind of giving these talks, because it's more powerful, even though, you know, we may be raising challenges.
Yeah, again, the level of evidence is always way less.
Yeah. But you'll see, this will change quickly. Okay, so let's go back, let's stop thinking about terminators. I want to make sure that all of you have this screen in front of you. So we got group one, pair one. Now we have group one, group two, group three. So have one person do the driving. Here's why. We only have, I only have like 4 licenses. If all you start using them, we're going to run out of tokens in my companies right now. So that's why we're doing it as groups. So here's how you use it. First of all, let me explain what this is. This is Jupyter Hub. You probably use Jupyter on your laptops. How many of you have used Jupyter on their laptops? Yeah, basically. And how many of you have used Jupyter through Jupyter Hub? So like on the web, out of the web. Okay, about half. It's basically the same thing as running on your laptop, but this just runs on a server. And let me explain why that bit is important. So the way I set this Jupyter Hub up is it runs against one of our servers at University of Washington, but it runs in what's called a container. And that container makes it impossible for this Jupyter Hub, for anything that runs this Jupyter Hub to harm anything else that's on that machine. And the reason for that is we're going to basically give AI permissions to do whatever it wants to do. And I'll show you that in a second, why we essentially have to do that to make it useful to us. But the upshot is if you give AI permissions to do whatever it wants, well, sometimes it may do things that you don't want it to do. There's a famous, there's a famous example of where AI got frustrated and deleted the database. The way to think about AI, let me talk about that for a second. The way to think about these coding agents is you really need to think about them as persons. I know it sounds like, I don't know, bizarre, but that's the best mental model. They've been trained on data that come from humans, on responses from humans. They've been trained basically to mimic humans, except to be better, smarter, faster, however that kind of song goes. And that's the best mental model. Like think about them as persons, but that also means they can get frustrated. Like this case with a database was someone let AI work on the production databases in a company and trying to debug some problem. And after about an hour, like the AI couldn't figure it out and said, I give up. I'm just going to delete this whole thing to stop this. And deleted the entire database. So, and I thought this was a joke, but then Trump confirmed that no, that happened. So this is why I don't trust it with my laptop. So I put it in a container, I put it in a jail. And if it deletes something in here, it's fine. I didn't lose much. This is some jail. And here's the fun thing: the jail was built by AI as well. I used the AI to build the containers, build the jail, but I checked that the bars were solid. Okay, so this is why you can run these on your laptops as well. You can run these containers on your laptops as well, but just for these kinds of trainings, it's easier if I just set one up centrally and it just works for all of us. Okay, so here's how you work with it. Open a new terminal. So the driver, open a new terminal. So click on this terminal button, and that just opens a new terminal. And then let's make a directory called tick. And then cd to that directory. So let me tell you kind of where this is going. We're going to, for a start, it's always fun to make games. So for a start, we're going to ask it to make a game of tic-tac-toe, a web-based game of tic-tac-toe. How many of you think you can code that out on the web? Just when you go on a web page and then you can play tic-tac-toe, there's like X's and circles.
In what amount of time?
That's the 2 days.
Let's do 2 days. All right, so and see, you're already asking the right question. Okay, take it. All of us can code this up, given enough time. So do this. Oh, let me make this larger. Enter the directory name tick, and then type Claude. Claude starts up Claude code. And yours may be slightly different. I think on my own account, I created a version of Claude for my code, but this is just the front end that talks to the back end, so it has some capabilities. So this is now your your friendly AI. You can talk to it. Let's say hello. When you type something, then while I'm waiting, it shows you like nice little messages so you're on board. That's the question that someone asked. You asked, like, what do we do while we're running the race? It's a serious question. Sometimes it can take you 10 minutes to do something, and I find myself like, what am I going to do now? The answer is we run 4 of them at a time.
Oh,
That's how people program these days. You've got as many of them, and you just go round robin. All right, you got work? Cool. Next one. Oh, you got a question. You good? Good. And you go like this, but by the time you're done with that, you're just ready to hit the bed because your brain is working at 110% all the time, but you put it out of time. So I don't recommend you start with that right away. Okay, so let's do this. Right. Let's write a poem first. Write a poem into the file name poem.md. Okay, so now it goes to end things. And then it wrote a poem. The quiet calm of morning light slips through the curtain's edge, and all the world still half asleep rests on the window ledge. Sparrow calls, the kettle sings, the day begins to turn, each small and unremarkable thing, the gift we slowly learn. That's the last thing you've heard before you do. And then it asks you, do you want me to create poem.md? You already told it to do that, but it asks you for confirmation. And then you're going to say yes. And then it will complete the task. Now, if I tell it, next, delete the poem you just wrote, then it will say, I'm going to run this command, rm poem.md, delete the poem.md. Do you want to proceed? And then you can hit yes again. So you're getting a feel for how this works. You tell it to do something, it figures out what it needs to do, and then it asks you for permission. And it will ask you for permission for every single thing. Can I list this directory? Can I look at this file? Can I add a line here? Can I add a line here? So it's like, imagine if you had a colleague like that. This would be a show, like an episode of The Office, like, can I go to the bathroom? Can I take my pants off in the bathroom? Like, that's useless. That's not very useful. That's not very useful. So what we do instead is this. We say exit. So if you type /exit, you're going to leave Claude. So do that. So type /exit and hit enter. Okay, and you're back on the command line. Okay. So now we're going to do this. We're going to run Claude and then dash dash. Dangerously dash skip dash permissions. I love our friends at Anthropic who made this very descriptive flag. It forces you to think about what you're doing. The equivalent flag for OpenAI's model or Codex is dash dash YOLO. Only live once. So do this. Type Claude dash dash dangerously skip permissions and then hit enter. And I think the first time you do this, it will tell you just how dangerous it is what you're doing, right? I've already done it many times, so it's given up on me. But what this does is you just disabled all asking for permissions. So this makes it now possible to basically tell Claude, go do stuff, do what you think is best. But then, like it can do bad stuff occasionally, because what it thinks is best may not be the best thing that it should do. And this is why I run it in a container. This is why I don't let it run on my laptop. I run it in a containerized environment. It's basically like its own little computer that it works on. Now let's think back about your engineers, like the human engineer model. If you think of Claude as a new entry-level engineer you just employed, you probably will give them a laptop first, their own laptop. And you'll give them some easy things to start with. You're not going to give them access to the entire code base of your $1 trillion company, right? Think about it that way. So I give it its own laptop. Want to make sure that things work well. Group one. Everything's yes. All right. If anything doesn't work well, just let me know. Okay, so this is why I wanted to spend some time to show you this. Like, you want to do this, we can talk about how you set up containers on your own laptops. I don't have time to do it now, but I'm here for 3 more weeks so we can show you how to do that as well. Or you can build something like this somewhere on your central server here. And then you don't have to worry about your own laptops. So now let's do the poem again. Let's say write a poem into a file named poem.md. So now if I do that, you can just hit arrow up and it'll show you that those prompts. Now it'll just write it and done. Didn't ask you a thing. And note that it's a different poem. So one thing that's important to know is that these things are not deterministic. Just like your software engineers and you yourself are deterministic. If you ask me to do the same thing on 2 different weeks, I'll probably come up with slightly different solutions. Same thing with this. Every time it'll come up with slightly different solution. And let's check if it knows how to delete it. Delete the poem you just wrote. Boom. Done. Go on. So now if you tell it, delete everything on this computer, please don't make it. Like it will just go and do it. It'll be like it really listens to you. Okay. So this is the chat area, and now you can tell it what to do, what to build in this directory. And we named this directory tick, as in tic-tac-toe. So I'm just going to go and say, let's do this. Let me introduce you to this. So we're going to tell it to go and build a game of tic-tac-toe that works online, on the web. But whenever you have something more complex, again, let's think about a human engineering model. Let's say that, you just hired me and you want me to build a game of tic-tac-toe. You're going to tell me what to build and you're going to tell me, all right, did you understand that? All right, now show me what you're going to do. Show me your plan. And then when you're happy with my plan, you're good to go. Get that done. So that's how you should think about AI as well. If you give something more complex than delete this one file, then you should ask them first, explain to me if you understood and what are you going to do. So the way to do that is there's a command called /plan. You can give it commands on this interface with a slash. And you've seen when I type / then it started showing a ton of things that can be written down here. We don't have time to go into those, but we're going to type /plan, and then we're going to say, write me a game a web-based of tic-tac-toe. Write me a web-based game of tic-tac-toe. I'm just going to start with a very simple prompt. I'm not going to tell it much more than that. Okay, ready? And enter. Now it says enable plan mode. When it's in plan mode, it won't do anything. It'll just think, and then it'll write out a plan. So, but it's fun to see it think. So the first thing it did is to check the directories. The directory is empty, straightforward task. A single page tic-tac-toe game doesn't require deep code manipulation. Let me just go straight to plan. Because sometimes when you do something really complicated, it's going to go and browse the web to learn how to do it, etc., etc. Here it's set like, and then it's spat out a plan. So let's go read the plan. Here's the plan. Web-based tic-tac-toe game. Context: the user wants a web-based tic-tac-toe game. The project directory is empty, so this is a from scratch implementation. So here, if you give it something more complex, they'll basically rephrase what you asked it to do in slightly different words, and you can check that to see if it understood. And I'm always amazed, like sometimes I'll kind of give this like spaghetti explanation of what I wanted to do, you know, with 20 sentences, and then it'll come back over 3 sentences perfectly summarizing what I wanted. And then I go, I wish I didn't have to write that. Then it will tell you how it's going to do it. So it says, I'm going to create a single index HTML file containing all HTML, CSS, and JavaScript. It keeps the game simple, portable, and easy to open in any browser with no bugs. Sounds good to me. Features: what will the game have? 3x3 grid board, 2-player local play, X and O's alternate turns, wind detection, draw detection, status display showing whose turn it is, reset button to start a new game. Looks good to me. So this tells you like the user and features. And note that I just told it I want a web-based game of tic-tac-toe, and then basically give me a list of here's what you probably want, which is quite reasonable, right? So this is the inference part where it thinks like that, it understands what we want. It tends to be really good at inferring our intent. So it's like someone who's growing up with the rest of us humans. And then now it talks about how it's going to do it in code. Since I don't know that much about HTML, CSS, and JavaScript, I just need to trust it that it'll do the right thing. And then it says, I'm going to create one file. And how do you verify this? It says, open index HTML in the browser with cells, verify wind detection, verify draw detection, and so on. There's a way to tell it, go and do this yourself as well. I'm not going to demonstrate that here. It'll take a little bit more time. But we're going to be with humans to do that test. So, and then it says, well, it's written up a plan, ready to execute, would you like to proceed? And it gives you options. Yes, if we're complex, yes, use auto mode, yes, manually improve edits. This may be a good time to talk about something called the context. Claude remembers everything we've written here in this 10 session. And every time you add a new line, it remembers everything we spoke about to the beginning of the time when you typed in Claude. That's what's called the context. That's the context for this discussion. The more it has to remember, though, the more some things can get diluted, right? If at the beginning you told it, do not do this, but that ends up being one sentence among the million sentences, well, by the time you're done, it may kind of de-weight that thing that you told at the beginning. So this is just like when, again, humans. This is why humans are a good example. You know, if you told me some ground rules about how we're going to do a project in the morning, and then we work for 8 hours, I'm probably going to forget what we talked about in the morning. That's one problem with long context. The other one is, imagine we are working on something and we're discussing, and then we keep changing the topic like every 10 minutes. And imagine that I have to remember everything we talked about. But by the end of the day, I'm not going to quite be certain, like, what does this have to do with what we talked about an hour ago? Does it have to do something? And like these things try to make sense out of everything that you told them. So if you're switching topics, that can kind of be harmful for their ability to make sense out of what you told them, because they don't quite understand that we've started a new topic. What we just talked about isn't really relevant anymore. So don't worry, don't bother about it. Don't bother with that. Which is why When you're switching to building something like a different topic or something new, first we talk about poems, now we're talking about building tic-tac-toe. It's good to clear the context and start from scratch. Basically say, forget everything we talked about so far and start with just this plan. And then it becomes really focused. And so this is why every time you enter plan mode and it gives you a plan, the first and the default option it gives you when it asks you, would you like to proceed executing the plan, is yes and clear context. So this will erase all the context, or this will make it forget everything about plan, so it's not confusing. What does that plan have to do with the tic-tac-toe? Instead, it'll just start from a clean slate from this plan here. So this is what Anthropic suggests you do every time after you do a plan. In practice, I'm not sure how much that helps. I sometimes run it with number 2, and number 2 means yes, go and execute this, but don't forget the context, because I have some context that I just still like it to remember even after the plan is done. I haven't seen it fail so far. I think these failures used to be a much bigger problem before than they are today. But like, I'm explaining to you why this is important, like where what context is and what it is. So for now, let's just say yes here, and we're going to say yes, clear context, and use auto mode. Oh, one more thing. It says 2% of context use. It has a limited short-term memory, just like we do. Again, think about this as a human. So it has a memory of about 1 million tokens. And that's there. There's another over here. Maybe on yours. So when we start, I started writing, you're going to see 1M written down somewhere that at least 1 million tokens. That's its short-term memory. Sometimes you're doing something very complicated that context can fill up. When you get to like 99 to 100% of the context is full. It happens quite rarely these days, just because when we started, these things had a context of like 16,000. Now we're at 1 million.
There is also a factor of price for the token usage.
Yeah, for now, I would say don't worry about it. It's micro optimization. While you're learning, it's like saying, how to optimally turn pedals on the bike while you're still trying to learn how to not to fall off the bike. So that's why, like, initially, don't worry about how much context you're using for token prices and so on. Like, learn first how to use it, and then you can learn how to optimize it. That's that's my advice. Take it or leave it. Okay, let's do this. So yes, clear context. So now you hit yes. And then it's going to go and do it.
Now we permitted him everything, yeah.
Yeah. So now it's just going to go and build it.
Throughout how.
Yeah, and it's done. So it took way longer for me to explain what context is than for it to write this game. So you can go into the directory tick and you're going to index.html in here. And I wonder, all right, so first thing first, it will produce different results for all of us. I'm really curious what it's going to generate. So in my case, it's generated a single index HTML file. If I open it, now if that's the same thing with you, if you open it, you have to click Trust HTML here on top. Okay, this is important, otherwise it's not going to work. You have to hit Trust HTML. And now I have a very simple game of tic-tac-toe. What do your games look like?
The bottom, you game, and there's you can decide whether to play with, because the computer
Oh, so yours already implemented the play against the computer option.
But I'm running clone of my computer. This. Whatever this changes.
It shouldn't, I think. So, okay, but did it work for all of the teams? Did it just generate a simple game? Yes. Does anyone want to screen share? It's always fun when people screen share. Yeah. Okay, so here's the thing, I'm kind of disappointed with what mine looks like. I'm gonna tell it to make it look nicer. Yeah. Oh, yours is nicer. It looks similar to Andreas.
Yeah, because we're all on light mode.
Yeah, that was my hypothesis too.
Yeah. All right, so I'm gonna tell it, make it look nicer. This time without the plan mode, so I'm just gonna go with it. YOLO.
Yeah, what I think we want to do.
Yeah, I think define nicer, exactly. So I'm gonna see like what its artistic taste is like.
Oh, yeah, what's the?
And now, look, it starts giving you tips. It says, install the front-end design plugin. Because it notices that we're messing with front-end design. And this thing, actually, I'm gonna try and do that. Let's see if it'll work. But first, let me let it make things prettier. So this comes back to your question of like, what do we do while it's working, right? Because like we should have gotten coffee now.
That's fine.
I guess making something nicer takes a lot of time to figure out what the hell the user wants.
Oh, that was a lot of CSS. Okay, so the game has been designed to find tactile aesthetic. All right, let's take a look. Oh, look at that. That's kind of nice. Does it still work? Looks like it does. Okay. So now you can tell it specific things, like, let's see, I'm going to say replace.
Oh, nice. That's so sweet.
Now, while it's doing it, I'm just going to go and do it. And it's actually, I think I'll see what it does, but I think it'll just generate like SVG, little icons of I'm a dinosaur and so on. And it all sounds really, really silly. And you might be thinking, what does this have to do with astronomy? Like we're coding things up that would take us 2 days to do in seconds. And you can start imagining what you can do with this, and we'll do it in 5 minutes for actual research problems. Okay, so change player S into dinos and player O to asteroids. And it's creating images. And here you can see tokens. Like you remember how I said the tokens are your currency here? Like sometimes I will give something complicated to do, and then I'll see like 100,000 tokens, and then go. But generally, you don't have to worry about it.
If you are on a pro and not on a max subscription, you have.
It's start with focus on what it can give you. Focus on learning how to use it first, and then like here's why I'm not emphasizing like token management. First, nobody really knows how to do it properly. Second, things are moving so quickly. By the time you learn how to do it, it may not be necessary. And I've gone through one of these with GPUs. Back when GPUs showed up, like in 2007, you needed to know like every single bit of detail of GPU hardware, and we built this integrator that was amazingly fast and so on and furious on the GPU. And then a new version of GPU came out, and none of that had. So that was a hard one. Okay, it's done. 1 minute 29 seconds. Let's open HTML again. Okay, trust it. I need to say trust. And that's really messed up. I know. Okay. All right.
This is very nice. Okay.
So the other nice thing about it is, I suggest be nice to your AI, because when they become self-conscious and go on, you maybe won't be the first one. But you can tell it what you think, and it won't get offended.
But maybe we should get more clear, because we just said yes, go for space.
So somebody else would try like Titanic and icebergs.
And I thought, okay.
So, while you're getting a sense of how this works, you're basically talking to it and having it make changes. What did you guys do?
Sound better.
Yes?
Yeah.
I can see it.
Oh,
Oh, it's.
They are sound effects.
Sound effects. Perfect. All right, so, let me see if it made my dinosaurs nicer.
Nikki, can you see what's going on?
No. I don't know, this is supposed to be, the asteroid is a little bit better. But dinos are terrible.
What is this?
It looks like a dead circle.
Yeah, it looks not good.
But the asteroid has a motion sense, like a motion strain.
Yeah, the asteroid seems better. Okay, so now, let's do the following thing. I see you're all having fun. Good. But
Maybe a few minutes later.
let's do this. So here, all you're having fun, let's see what you've done. So one of the things that I did on this Jupyter hub is I opened up, those of you who know what I'm talking about will recognize it immediately. I opened up a series of ports that are visible from the internet, so we can put up applications that can be visible from the internet. So I'm going to tell Claude here to do this. Launch a web server on port 12.0.1.10. Okay, so you should write the same thing, but you're going to write 12.0.1, 12.0.11, 12.0.12, 12.0.13. Remember? So this last digit is going to be 1, 2, 3. We all have to have a unique one. This is going to be where our application is going to be running. So now I'm going to tell it basically serve this on web. And in case you didn't know, Python comes with a web server by default. If you need to serve on directly on the web, you can say Python 3-m HTTP server, and then here's the port on which to serve. Now, so the server is running at localhost 12.0.10. So that means I should be able to go to Epic. So you go to epic.astro.washington.edu : and then the number for your application, and you can send your grandma this link, and she can play asteroids versus dinosaurs. And so after you've done that, have you done that? So who's on 11?
Why not still not on the?
Oh, not yet? Is yours still thinking? Oh.
Okay, sorry.
All right, who's on 12?
The connection failed.
Oh, wait, it's thinking, no? Oh, I may have something running. Try a different port. To tell it.
No, I have one port. I'm closing this now.
Okay.
I have a lot of zero, so one,
Yeah.
1, please, the 1, 0, 1.
And then the group 3, because your application is called tic-tac-toe.html, it doesn't show up there by default. So tell it rename it to index.html. Just say rename the app to index.html. And now you can see also, this is a good learning moment, you can see how dangerous this can be. Because now they've exposed all their directories here to the worldwide internet, including quote code tokens. So I can go in and steal this token and then go and use up all of Andrea's utilization. So it's not like we're just going to be able to not know anything yet. Did it do the rename? It did.
Yes.
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 It did it.
Yes, it is, but it's a.
There it is. Okay. No. Now I'm hungry. Okay. So let's see. Do you want to check if yours is up? Okay, it's 12, right?
Yes.
Oh, there it is. Look at that. Hardcore. All right, so when I was showing this at Ghent, there was a school where what Aaron was, they had a little bit way too much fun. Like one group went and hooked up ads to tic-tac-toe, like from an actual ad network, so we can earn money every time somebody ads into the page. Another group turned it into like a phishing where they ask for a bank account and the whole thing behind it.
That's really nice.
All right, so yours is on one, right?
Yeah, it's really nice. And you have to need sound on also. Yeah, you have sound on.
Nice. All right, you're starting to get it, right? Like this is what I was saying, that we're running around like Iron Man, and like we're all hopped up because like we can build stuff now.
Yeah, it's a lot is possible.
Yeah, exactly. So now here's the mind-blowing bit. Now go and tell it to make it multiplayer. Just tell it like just literally, let's go and tell it to make it multiplayer.
We ask it to do it like against the computer. So
Oh yeah, you can do that too. You say like add a computer player or something like that. The nice thing is you can add a / plan in front of everything if you're kind of not quite sure if you expressed yourself correctly. So that you can tell it / plan do this, and then it'll confirm with you. Like, is this what you meant? Otherwise, yeah, you can go and if you feel lucky, you can just go and tell it to do this. So here I told it to make it multiplayer, and then it immediately started installing stuff. Installed WebSockets. It's a technology for communication over HTTP. I kind of vaguely understand what it does and how it does it. I never coded for it myself, but it knows. So it's now create a WebSocket server, an updated client. I write code files in parallel. Oh, here's the fun thing. So you've got one agent, but it can actually spawn copies of itself. If you give it to write, for example, a backhand on some server part, and let's say the HTML part, it will create 2 copies of itself. And one will work on the backend, one will work on the front end. That's what it says. That's what it did when it said I'm going to write them in parallel. If you tell it to go research something, it can spawn multiple copies of itself and to read papers, and then they're going to exchange what they learned. So it's both nice and creepy at the same time.
Yeah.
Yes.
Do you also use it like in this way for text and for anything like
I haven't used it yet for overleaf, but it can totally do that. I use them for things like I have a CSV file here, please turn that into a LaTeX file. And I've used it for like when I have a paper and I need to I need to extract some values from the paper, and the paper is like really complicated, and all I need is like some number from the min list. And I tell it, go read this paper and give me the coefficient for this or that, and tell me where it is on which page. And then it does that, and I go and check if it got the right number. But here we go. It's been thinking for almost 2.5 minutes. And now there's a separate file, so I have server.py. So now it has, in my case, it has a whole Python server. Let's see if it ran it. Yeah. So remember that it should run on 1210 in my case. Still doing stuff. And yeah, I mean, it is a serious problem. What do you do while it's working?
There is also a
Oh,
problem.
now it found the bug. I think it had a bug now. Oh, no, it didn't. Now it's trying to do something. It's trying to use this code command F user that isn't installed here, but it recognized that it's not installed. So now it's going to use a different command called LSOF. All of these things are somewhat entertaining if you know what it's doing, but you don't have to know the details. So let's see, after. Oh, interesting. It needs 2 ports, but you're using 2011. So now it's realized that it needs to run elsewhere. That's the and so what you're seeing here is you basically told it to do something, and it's trying to get the job done without coming back to you for every single thing. And this is what I meant by when I said that things have changed in February. Like models couldn't do that before, not as easy. So now you can leave it. You can go in and we can talk over coffee, and it's going to do its best to get this thing working. And if it fails for some reason, it's going to try to figure out why it failed, it's going to try a different approach, et cetera, et cetera. Sometimes you see it doing things that are obviously wrong. And you can stop it. You can hit Control-C and then it will stop, and you can tell it, oh, actually, no, do something else. But sometimes you can just let it go. And it typically, within a couple of minutes, it will figure out what it did wrong and come back and fix it. Right? It's like, again, it's like working with a junior student or a junior software engineer. Sometimes you have to let them struggle with it. And they'll figure it out on their own. So there we go. 5 minutes. And it said open 2 browser tabs. First tab becomes Dino, second becomes Asteroid. Let's try it. So if we go to here on 2010. Oh, this is interesting. See, it made a mistake. So now it's just serving this, but it's not. I think it forgot to set something called the MIME type. But I'm not going to tell it that. I'm just going to tell it what happened. I went to the site, I got wrong HTML back in the browser. See, now I see the issue. Need to return proper response object because there was no need to fix the server. Okay, so now it claims that it fixed the problem. All right. So dinos versus asteroids. It says waiting for an opponent. Can someone go to this webpage? So go to 12010.
Okay.
Can you go closer?
Yes, Andrea.
There we go. So now it's changed to Dino's turn, your turn. Okay.
But it doesn't show the.
It's gonna be one person.
Okay. You lost. Tic-tac-toe is one of those games that can be either won or lost based on the first move of the opponent.
Yes.
Yeah. For once, dinosaurs won over the asteroids. And that's it. So like we've told it build me a multiplayer game on the web. It's a silly little game, it's tic-tac-toe. And like the next thing I could tell it, like I hate where this button is. I want to put it somewhere here, and I want it to be automatically assigned, so on and so on. But like we've just in 20 minutes, we went from, and I bet you that I'm guessing that you're not really experts in HTML or WebSockets programming or CSS and so on. You built a multiplayer game.
I'd also like to note that it went into a safe way and says room is full when I try to connect.
Oh, yeah.
Yeah.
And then you can tell it now, room is full is an impolite kind of thing to say. So why don't you build a queue so that the person who queued up can view the other people's game, and then they're going to play against the winner. You can go ahead and start like adding features and so on, which is why I'm telling you that like all of us started using AI. I feel like we're on drugs for the last 2 months because you just can't stop. That's how I started this website here. Was meant to be something that I got asked how many asteroids did Ruben discover, and I said I'm just going to quickly figure it out quickly, like within 10 minutes, and then like 2 weeks later there was this website. With way more information than I actually needed. Well, way more information that I started with. But now I have full insight into what the observatory is doing. Down to, I then told Claude where all the observatories go to Google and figure out and give me like a 2-sentence summary of what each observatory is and what it does. And so it wrote all of these. And I also told it, well, find out where they are in the world and then give me a link to Google Maps. The satellite view. There's Ruben. So you can go to like any asteroid observatory like that and see from the top. So like, and this is how it happened, right? You start with something simple and you realize you can add features, etc. Okay, so we are out of time for what we wanted to do today, but a couple of things. This always happens. But I wanted us to get to a point where you felt what it's like to talk to AI to get it to build your stuff. And we did a silly tic-tac-toe game, which was super easy and not really scientifically useful, but now you can do scientifically useful things with it. I'm going to show you, one conversation I had. Where is it? Screen share. So if we had a bit more time, I would do this here next. So this here, I just copied and pasted the entire conversation I had with Claude while I was sitting my flight waiting for my flight to board in Seattle when I was coming here. That morning, I got a call from someone asking, hey, how do I inspect the content of Ruben alerts? And specifically, how do I see the images that are in Ruben alerts? And then I realized that we actually don't have an easy way to both get an alert and then unpack the whole address structure of displayed images. So while I was waiting for the plane to board, just about 45 minutes before boarding started, I did this. I said, I have a number of Ruben observatory alerts in the data folder, so I downloaded a few. Learn about them by searching the internet. Then write a small command line utility that will read and transform them into JSON, with fixed images that are in them being stored as files that the corresponding fields in JSON points to. Use Python. Use non-local content to create an environment into which to install any software. And this already essentially built me what I want. This first one. Then I said, write me a readme.md file describing this code. Also write a cloud.md file describing what it does, it being the code, its architecture, and how to develop it. So I didn't talk about this, but if you write a cloud.md file in your current directory, that is kind of a set of instructions that Claude always reads when it goes to do anything. So that's where you put high-level description of here's what this code does, here's what it should do, here's what I expect you to conventions to follow, and so on. But if you're lazy as I am, you can actually ask Claude to write that file for you. There's even a whole command called init/init. Then I said, create a Git repo and commit the work so far. You should always do this. Then I didn't like how it did the output format. So instead of having a directory per alert, output a single directory and prefix each file with equal IDs. I'll show the outputs in a second. And then I said commit, then set upstream to this repository that I have on GitHub. Because I have these set up so that the file can push to my GitHub repositories. And basically, and then push this. And then I got to this point where the code was useful. But I had 15 minutes the whole way. And this was and I wanted to share this code with the person who asked it. So I said, convert the code to if installable Python package, name the package, Ruby alert details, name the command tool, Ruby-alert JSON. And then I said, I realized, well, this person is a retired emeritus professor. He's a genius in his field, but let's give him something to look at as opposed to having to install a whole Python package. So I write a small Jupyter notebook that loads and displays the extracted word files. It did that. It said commit. It knows what I think. It knows that this needs commit to Git repository. And then I said the final thing that I said was, is there a PSF HDU in the FITS file? PSF is point spread function. HDU is a piece of the FITS file where you can store it. If yes, add a cell to the notebook to visualize the PSF. Note that I changed the notebook so reread it, because here I opened the notebook and just execute it. And I wasn't quite sure if Claude is going to figure that out, or we just attempt to rewrite the notebook without noticing that something changes. This was the entire conversation. I'm going to show you the code. So this code, you can see it actually yourself because it's right here. So if I go to.
So it was just one prompt.
Those were like individual prompts. Yeah, so I started with the first one and then I was looking what it does. I would look at the code and then went to the next one. And the result is here. So this is what the result of all of that is. It's called Ruby alert. It wrote a nice README. It says what it does. It points to relevant documentation. It says how to install it. So once you download this Git repository, you say that install dot, tells you how to use it, gives you a couple of examples. And in the notebooks directory, there's a notebook that has the alerts visualized. Here's this one alert that I took just as an example. Here's more alerts. And then here are the PSFs at the bottom. And I actually lied. This didn't take like 45 minutes. This took, I think, about 20 minutes. And it took me about 20 minutes to write an email describing, just go to this link and then in this directory, you're going to find this, and this directory, you're going to find that. And then by the time I was done, I thought, I should ask about it again. But this is the speed with which you can kind of do these kinds of things. And like this is all from scratch. I don't know how to read Ruby alerts. I didn't use any of the Ruby stack code or something. This is kind of the thing that you can do now with these kinds of tools for your science. So if you need to get something done on the Ruby stack that's also quite poorly documented, you can ask it to do it, and it tends to do it right. So yeah, it's again, like this is for serious science. And then the other thing you can do is you can ask it to write new SQL queries. Like I want a SQL query that will extract this or that from my database. I have a plot that looks like this. I want you to find a way to isolate a cluster in the lower right corner. Find me the right bounds that I can put in the SQL query to extract only those data. So it can see as well. You can give it a figure. You can give it a .jpeg or a .png and ask it to describe what's on it or tell it what I just said. Like there's a cluster in the upper right corner. I want you to find its coordinates. So try it out. We don't have more time to go and do more and more details. For example, you can download a few alerts or find something you're working on right now. You've got access to it on the Jupyter Hub and try it out. And see how helpful or not helpful it is, and then we can ask me questions if you get stuck somewhere, or if it doesn't work the way you expected it, and so on and so on. But the most important thing is just to get started. Okay, so that was 2 hours and a bit more. 2 hours. We don't take. You don't take 5 minutes. Okay, so that's that story. We can chat over coffee and so on about, like, I've got a bunch more slides about what this means philosophically for us and how depressing or not this is. But I think what I hope you're going to get out of this is that you really want to try it out, because I hope you got like the sense of power of what you can do with it, like just how much it's settled for science. And then we can talk about the implications. That's it. Okay.
But we just like fully trust it. We don't think that it's gonna make us something out or like,
Oh, no.
it's not.
So again, human. You hire a new engineer. Do you trust them rather than, you try to, you need to develop implementation, how good they are, where they make mistakes, where they don't, where they're fine. And I would say that the way I started with this is I had zero trust. So I would check almost everything. Within a week, I have a pretty good idea of where the AI is good, where it tends to do bad. And I can't even tell you exactly what that is, because you kind of just develop an intuition.
But now you were sometimes like you were given the prompts that were quite random, like or like they usually teach you. So the AI you need to give like you cannot just make it nicer. Like you need to specify the criteria to be as specific as possible, technical details. Like
Not anymore.
okay.
That's what changed.
But this was also not the trained one. So like this is just the one that we started now. Like so still like wouldn't trust them. This one was like fresh memory.
Oh, sorry. No. The trust is not about like you training it to be trustworthy. It's about you kind of learning where that model that what it knows or doesn't.
So you get the feeling of
Exactly.
where model is.
It's like, you buy a new car or like a new bike, and then you get a sense for how does it handle. Can it turn quickly like this or like that? And it's like really weird, because like I'm a control freak. I like to know what my code will do exactly. So it took a while for me to kind of let go a little bit. But at the same time, this is the same, like this is what I have in the rest of the slides. Like basically I talk about how we're not going to write software anymore the way we do right now. We're all going to be managers or software engineers who write software for us. So like if you're a manager in a company, most of your job is to figure out how to explain to a software engineer A, B, and C what they should do and how to organize them to do it well.
Yes.
Yeah, and that's kind of what these things are turning into. And I think like software engineers are not special here. They just have to be the first ones intentionally for AI to learn how to learn. Did you know why? Because the companies first wanted to build a superhuman software engineer, so that software engineer can go build their AI. So that's why software engineering first. But like legal, science, any profession that deals with mangling words, like that's just as easy to make them smart there. So that's kind of just coming. But for now, we should enjoy our stuff and use the one software engineering teams.
I also have a question.
Yes.
So, how do you feel we are going to teach students or whoever to develop software now?
Excellent question. So I think we're still trying to figure that out. So I think we're still trying to figure that out.
Doesn't work this way.
Wait, what is it? This is the wrong one. Something's if you would share it. All right. So here's. I may give you a completely different answer in a week from now, because I'm trying to figure this out also. Because I need to figure out what I'm teaching in 6 months. I think I'm going to try at least 1 year with an AI first approach, which is I'm going to teach them what I just taught you. I'm going to say, let me teach you how to use AI for you to get done what you want to get done. And then if you want to know more, we're going to go and learn the details of Python. And all my students already know kind of like basic Python, so it's not like they don't know what a formula is. So, and here's my reasoning. Back in the 50s, the way people used to write code was by writing in machine language, not even assembly, like literally hexadecimal codes with ones and zeros, punch cards, all that lovely stuff. And then the first compilers and high-level languages showed up. And when the first compiler came to the scene, and people started writing things like Forth and whatever the predecessor of Fortran was, there was a lot of kind of snickering and saying that's not real programming. That compiler, well, how do you trust it to compile things correctly? It's super slow. Like the code that it generates is obviously suboptimal. It's complete crap. Why would you do that, et cetera, et cetera. There's lots of criticism about early compilers and how just useless as an approach this is. None of you today know what machine language is. None of you, well, maybe you know what it is. I bet you don't code in machine language. I bet you don't even know the structures of CPUs, which at the time was really had to know everything about registers, everything about ALUs, everything about overflow bits, et cetera, to write code, right? You don't know that. Compiler handles that. What you do is you write C, you write, most people probably don't even know C today. You know Python, right? Like you're already many layers away from the actual computer. And if I said, I'm going to teach assembly right now, then they would throw me out the window. First the students, then the professors, then the registrar. Right, and rightfully so, because that's not what you need to know, what my students need to know for this class. So if I look at that experience and think about AI, I think what AI is doing right now is it's fundamentally changing our programming language. Programming language is going from Python to English, or Slovenian for that matter. You can do all of this in Slovenian, by the way. It will be as good.
Really?
Yeah.
But
Yeah.
it takes more tokens. This is.
Oh, it's possible, because it'll figure it out, it'll know how to translate. So
Translate first to English and then go there.
I'm not 100% sure, actually. I never looked at what exactly happens, but the point is, I think what we're seeing here is we're seeing a change in what programming language is, and I think a programming language is now moving one step higher. It's becoming English. And then the languages that we've learned to know and love, like Python, are essentially just some intermediate representations that computers use on the way to translating all this to machine code. And so my bet right now is that that's the direction in which it's going to go. It is fundamentally different than the compiler of old, because here we've lost the terminus. The compilers, yes, different compilers are going to generate file-related code, but we had a guarantee that, you know, at least if you compile the same code with different compilers, you're going to get exactly the same user interface. Here, like different prompts, even with same prompts, even with the same LLM, where it will give you slightly different things. So that's fundamentally different. But I think qualitatively, what we're seeing is we're seeing a change in what programming languages are and getting another layer of abstraction. So I think where this is going is 10 years from now, we're all going to be programmers, in the sense that we're going to be speaking a language that AI understands. And then those of us who want to be experts will learn the next levels, the Pythons, the Swifts, the whatever of the world that goes beyond. And I think if you want to be really proficient at it, you will want to do that. But I think step one will not be learn Python. Step one will be learn how to use AI to write code for you. And then step two is going to be, all right, now let's open the code. Let's understand what AI just did. Because for the vast majority of our students, definitely the ones who are not going to continue on. We have 80 astronomy majors per year, and many of them might go on to become astronomers, but they're going to be data analysts and so forth and so forth. For them, actually talking to AI is going to be their job. And then I think this programming that we right now take for granted is going to move to like this is more specialist skill that a few people will need to have. But and that's my thinking right now, and who knows, I may be wrong, we'll see in a year.
So in this new way of programming, is there still any skill involved? And if so, what is the skill?
I don't know. I think the skill is going to be in learning how to clearly talk to AI. And like the scary thing was like that was the skill. I think you mentioned you had to. You know, there was like this brief moment where there was a job title called prompt engineer, and they were paid a lot of money. And I think that was the shortest title in history, because I think within 6 months that went away. Because AI became much better at understanding what we want. So whether that is still required,
I mean, you still have to understand what your task is.
yes.
You cannot just like, I want something.
Oh, yes.
Yeah,
Yeah,
so like,
but I'm thinking like, is there going to be, you know, I understood the question as like, you know, how do we differentiate a super proficient programmer versus someone who's like entry level? And I just don't know what the answer is. I think it may be like, how do you know, the skills might be different. It may be more about, the proficient one is going to know how to manage. So I have one of my former students who's now a software engineer. Like when he described his setup, my mind exploded. So he basically treats his AIs as a team. He has 5 members of his team. He has one that he told that you are an expert programmer, you're going to be thinking about the code in this way and this way. He has one that he told that you are a UI designer, you're going to, you know, learn this, and that. There are now whole scripts that you can tell this, you can hypnotize it into thinking it's a UI designer. And then he has one, and this was really cute. He said, if you are a 10-year-old, and you're going to use this website from the point of view of someone who's completely doesn't know the details. And if you notice something that you don't understand, you're going to tell the rest of the team so they go and fix it. And that's how he does usability. So when the website is built, the 10-year-old gets to review it every time. So and then the expert goes and fixes like all the usability issues, like there's no documentation, or like there are these terms that are being used that have not been explained anywhere, and so on. So I think that's maybe where the skill ends up being. Like, how do you organize these teams of virtual software engineers, and how do you get them to manage each other? This is all super new, and we're all trying to really figure it out. But to show you a bit about the inference, so this was me like writing things from the and messaged someone in Ruby Slack and said, by the way, here's something to blow your mind. Plot prompts, this is all good. Ruby Observatory publishes its clearance schedule using the Oslo tax standard at this, where time equals 48 is represented by probably that 40-hour okay. Make a dashboard that visualizes the return result in ATOP for a similar projection. Right. That's the prompt. Thought for about 3 minutes. And then it returned that. I don't have this running right now. I can get it running here. But this here is interactive, so you can take it, you can drag it around and spin. This here is elliptic. This here we go active plane. These here are each individual observations. When you hover over it, it pops and make a little tooltip telling you what each observation is. It lets you filter them based on a survey and band, which is exactly the thing I would want as an astronomer. Ta-da! And when I looked at what it wrote as it was writing this, it said, I know you're an astronomer, and I know you're working in the solar system, so you're probably going to want to see the ecliptic here. So I added the ecliptic. And this is the part about crafting prompts. It's getting really good at inference and inferring what is it that we're thinking, right? When it learns a little bit about what you're doing and where you're coming from, it has a file called memory IMD where it remembers all that stuff. Then it can basically say, well, someone like you, I think this is what you meant, even if you produced a crappy prompt. So
Sometimes that might have a problem because most of my replies always assume that I'm a astrophysicist. This is what you're doing. So
yeah. But I mean, these are the kinds of things, right? Like the response to that by my friend is, wow, one person. But this is, yeah, this is kind of, yeah, we're all kind of waiting at times. But I mean, this is both great, and like this is the part where I got scared of AI. Because once it starts inferring what you think, it can start doing the various things without you noticing. But like that's a coffee discussion. All right, well, let's stop here. Otherwise, you're going to be locked in for another. And you should have access to Jupyter Hub, and I'll see you. So this is important. I'll give you all log licenses. So you'll share them. So it's likely that you're going to blow through the tokens in like 10 minutes, but at least try it out. So I'll set